All right, students. Oops. In order for us to get some accurate graphs, we're going to, of course, need to analyze these. And so let's do some practice. So we're going to find the x and y intercepts so that we can plot them, and it's where those interesting shapes are going to occur. So example number 1 is a lot of fun. Let's first find what the degree is. So we're going to count up how many x values there are. And so I can see that there's 1x here, there's 1x here, and there's 1x here. But the degree is not 3 because look at this one has an x to the third power. So this is 3, this is 1, and then this one is an x to the second power. So I'm going to add all of those up, 1 plus 3 plus 2, and I'm going to get a degree of 6. So this one's actually a 6th degree. So we count up all the x's when it's in factored form. So a degree of 6 means that there are 5 turning points, 1 less than the degree. And then the a value, I noticed the lead coefficient. We don't have a values inside here. So it's just going to be a 1, but I see that it is a negative 1. So that means that our end behavior, the y values are going to be pointing in the same direction. They're both going to be pointing negative or down towards negative infinity and negative infinity. So I'm going to sketch those right now to kind of support me. And then I'm going to find my x-intercepts. So remember I used the zero product property. So I've got x equals 0 or negative x equals 0. And I've got x plus 8 equals 0. And then I have x minus 2 equals 0. So I'm going to have 0, 0. And then I'm going to have negative 8, 0. But there were 3 of those. So I'm going to say multiplicity of 3. So I'm just going to say m of 3, which means, well, this one happened 3 times. So I'm going to expect to see that weird snake shape at this x-intercept. And then I have 2, 0, and that one also has more than 1 because of the exponent of 2, and that's a multiplicity of 2. So I'm just going to say m of 2. And so at this one we're expecting the snake shape, and at this one we're expecting the parabola shape. What about the y-intercept? Well, the y-intercept we get by plugging in 0 for x. So when I do that, I've got negative 0 times 8 to the third power times negative 2 squared. And 8 to the third power is pretty big. Times that by 4, because 2 squared, but then remember we times it by 0. So the y-intercept is 0, 0 in this case. So whenever we have an x as a factor, we have the x and y-intercept at the origin, which is just something kind of nice. So first, we found all this information. Now we're going to plot our x-intercepts, and I'm going to put my little helpers at each one to kind of indicate where I expect them to be. So I'm going to have 0, 0. And then I'm going to have negative 8, 0, negative 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. And then I'm going to be at positive 2. Okay, and then so right here I'm going to have a bounce. And then here I'm expecting a snake. So I'm just drawing those as sketches to kind of help me. So now I need to connect all of my dots to my end behavior. So I don't have to connect it exactly to that arrow, but I know I want it to point down. So I think I'm going to go like this, like that, and then pass right through, but then bazinga. Okay, and you see that for some reason mine just shifted down. So let's see if we fix that a little bit. There it is. And so we have one continuous line, and it matches the kind of funny guidelines that we suggested. So it looks to have an inflection. This one is just passing right through. We call that a shoot. And then here I had a bounce. And so this is really cool because I got to see all three features. Let me see if I can make this really look really nice. It's probably more likely to look like this. And so, rad. That's it. It's not going to be perfect. Looking at number 2. Well, this one is in expanded form or standard form, and so I'm going to factor this, but first of all I can see that it has a degree of 3 because that's the highest exponent, so there are 2 turning points. The a value is part of the lead coefficient and it is positive 1. So with an odd degree, positive 1, it means the x and y are going to go the same direction. So negative infinity for x, negative infinity for y. X goes to positive infinity, well, so does y for a positive a value with an odd degree. So now to find my x-intercepts, I will have to factor, but I can easily see the y-intercept because when I plug in 0, it's 0 plus 0 minus 8. So I've got 0, comma, negative 8. So I'll start by plotting that ordered pair, and there you go. Dios mío. Okay, so let's try factoring this. So I'm going to use factoring by grouping because it's a polynomial. And so I'm going to factor out the x squared, I have x plus 2. Then I'm going to factor out a minus 4, and I have x plus 2. And so then it's x squared minus 4 times x plus 2. And this factors further. That's the sum. Nope, that's the difference of 2 squares. And so that's going to be x plus 2, x minus 2. So I have x plus 2, x minus 2, and then this x plus 2. So what do you notice? Well, let me erase all this and we'll look at it. So I'm noticing that these two are the same. So that's going to create a multiplicity of 2. So I'm going to have x minus 2 times x plus 2 squared. And so that's going to give me my x-intercepts at 2, comma 0. And then at negative 2, comma 0 with a multiplicity of 2, which just means there's going to be a bounce. I don't know if it's going to be a bounce up or a bounce down, but there's going to be one. So plotting my intercept at positive 2. Oh, my graph is being a little bit weird. Okay, so I was able to plot my intercepts. And so now I have to sketch my end behavior. So I'm going to have an arrow over here. And I'm going to have an arrow in the other direction. And I know that this one here is the one that has the bounce. And so if I want to connect the dots and it's going to be going this way, the bounce is going to be going down. And this one is just a shoot. So this looks pretty good. Oh no! And my graph is going crazy. Okay. So I adjusted the picture so that it looks correct. So I have the bounce at negative 2 because that was the multiplicity of 2. I passed through at the negative 8 as best as I could, and then I just passed through at 2. My arrow is pointing up towards positive infinity and then down towards negative infinity, but I'm afraid to draw it because it'll just move my graph around. So this one was a lot of fun. We found the x and y intercepts and all that with factoring, and I just love all that stuff. So here's our third example. Looking here at the degree, I can see that again the degree is 3, which means there will be just 2 turning points. This time the a value is 2. And so that's a positive 2. So we're going to have the same end behavior as before with the odd degree and a positive a value. So the y is going to go towards negative infinity and x is going to go towards positive infinity. I am again going to need to calculate the x and y intercepts, this time with factoring and this time with a GCF. So I take out my x and I'm left with 2x squared minus 5x minus 12. And then I'm going to make my little t-chart off to the side, and that's going to be 2 times 12, which is negative 24, and negative 5. So I'm looking at negative 8 and positive 3. So I'm going to use negative 8 and positive 3 to split the middle terms, taking this space back. 2x squared minus 8x plus 3x minus 12. Now, just like before, taking out the GCF of 2x, so I have x minus 4. Take out a GCF of 3, again x minus 4. Good, those are supposed to match. So I have 2x plus 3 times x minus 4, and then the original x on the outside as my final factored answer. I'm going to erase all of this so that it looks lovely to look at. You're, of course, welcome to leave it on your notes. I just prefer to look at it this way, and since mine does erase, I'm going to. So I am going to find my x-intercepts here. So I know that this one, x equals 0, is 0, 0, which means that my y-intercept is also 0, 0. This one's very easy. That's going to be 4, 0. But then that other one, 2x plus 3, I'm going to solve by equal 0, subtract 3, and that's going to be 2x equals negative 3 divided by 2. I get negative 2/3. Nope. Negative 3 over 2, and that's going to be negative 1.5. That'll be the easiest way for me to plot it, is by translating it back into a decimal. So I don't have any bounces here, so this one is just going to be a few shoots. I'm going to have my end behavior here and my end behavior on the other side. Let me move this graph back down and see if I can keep it from being too crazy. So I want to put an ordered pair at the origin. I want to put an ordered pair at positive 4, 0. And then an ordered pair at negative 1.5. Okay, so those ones, see how they kind of stayed on the axis? That's great. So I'm going to just connect them. And pass through, pass through, pass through. And that's it. So this one was just kind of fun. It does kind of look like the cube function, but with a really exaggerated point of inflection. That's been like twisted around. So it's got 2 very clear turning points, end behavior. This looks great. So we're going to do some more practice problems in class, and I can't wait. We'll see you then.